Hello and welcome to another video. In this one we're looking at 6.4. This is going to be on functions. So to start out, we're going to begin by looking at the definition of a function. So it says a function is a relation in which each value of the independent variable is associated with exactly one value of the dependent variable. So what that means is every value that you're kind of inputting into an equation, you're going to get out exactly one output or one dependent variable. And the reason that was called independent variable again was because you got to pick the values that you put into the function. And then the reason they were called dependent was because it depended on whatever you chose for the independent variable. So another way to describe what a function is, it could be described as for every value in the domain, there is a unique value in the range. So for every one in the domain, there's one in the range. So it's a very special type of relation. So all functions are going to be relations, but not all relations are functions because not all relations have this special kind of one-to-one property. So a real-life example of something similar to this could be related with dogs. You could say all German Shepherds are dogs, but you can't reverse that and say that all dogs are German Shepherds. It's the same thing with functions. So all functions are relations, but not all relations are functions. So the way that we're going to be able to tell whether something is a function, if it's got this kind of one-to-one property, is going to be this VLT. So it's the vertical line test. So we only use it to see if a graph represents a function. So what we do is we take a vertical line. So it says if any vertical line intersects the graph at more than one point, then the relation is not a function. So if I drew a vertical line like this, and oftentimes it says here even, you can just use your pencil because you might not have a vertical line with you. You could also use a ruler. So if it crosses once, so there's one crossing point right here, that tells me that that is going to be a function. And you got to check everywhere on the line. So you're going to have all of these vertical lines, but on all of those spots where I test, it's only ever going to cross the line once. So that's what that word intersect means. That just means crosses. Okay, now if I look at the second one there, if I draw a vertical line, say here, it crosses once, twice. So that is not a function. Okay, so you got to check it everywhere because you couldn't just check it right here and get that it touched once, so it must be a function. You got to check it everywhere. So as soon as you come across one other spot where it crosses twice, it's not a function. So now that we know what a function is and how to test if it is a function on a graph, we're going to look at some examples. So on the left side there we got functions, and on the right side we have non-functions. So we're going to go through each one of these and explain why it is a function and why it is not a function. So if we look at the ones on the left here first for the table, we can see that 5 goes with 10, 6 goes with 15, 7 goes with 20. So each of those had exactly one output. There was only one thing that went with it. If I look at the other side, I got 6 went with 10. Okay, so 6 goes with 10. And then all of a sudden I got 6 goes with 15. So we can't have that repeating value in the x side here. Okay, it could repeat, but this would have to be 10. And now it's changed to a 15, so that isn't right. So that's not a function. So this here, we can't have repeating. So another way you could kind of think about this is think about if you had a bunch of different people. So if X stood for people, you could have the first person, second person, third person, all the way up to the sixth person. So if you had the sixth person, maybe they had $10. So I know person 6 has $10. Then I get to person 6 here again, and now it says they have $15. That wouldn't make sense, okay? So they can only have one output. you can't have a changing y value. So if I look at this one over here now, I can see for 11 gives me 3, 21 gives me 3, and 31 gives me 3. Now, I have repetition on this side, but repetition on that side is allowed, because you could have, say, person 11 has $3, person 21 also has $3, and person 31 also has $3. Okay, so you can have repetition on the range side. Okay, and just to remind you, the y, that was for the range, and the x was for the domain. So on this one here, the domain couldn't repeat. So I'm just going to put domain up here. Domain can't repeat to be a function, but the range can repeat. So looking at this last one here now, we got 3 goes with 11. Then all of a sudden it changes and it goes with 21. So we have that repeating here where it doesn't give us out the same value, and you can't have that. So the domain is repeating, therefore it's not a function. Okay, so we've seen those ones. Now with these next ones in here, these are just points all given to us. So with each one of these ones on the left here, I can see that -2 gives me out -5, 0 gives me out 4, 2 gives 13, 4 gives out 22. So there's no repetition of this first value, so we're all good. Then with this one, we got 10 gives out 10, 12 gives out 10, 14 gives out 12, 16 gives out 12. So all of those are fine. If I look at this right side here though, I can see 7 gives out 5, and then 7 all of a sudden gives out 8. So we can't have that domain value repeat and get out a different range. So these 7s, and even on the second one, these 12s, they repeated, but it gave out different range values. We can't have that happen. So domain repeated, but it gave out different range. So now we've seen it with a list of points. These next ones here, these are all graphs. So for your graphs, what you want to do is that vertical line test. So you're just drawing vertical lines, and they can only ever cross once. So on all of these on that graph, it only ever touches once. If I look at the next one, if I draw some vertical lines, anytime I draw a vertical line, it's only ever hitting one point. Okay, I could draw a vertical line and it doesn't hit any point, but that's okay. I just can't ever hit 2 points. So like these ones over here, if I drew a line here, that hits 2 points, so it doesn't pass the vertical line test. Or if I drew a line there, that actually hit 3 points, so it wouldn't pass the vertical line test. Even if you find other ones where they hit only once, this one right here, it hit 3, so it doesn't pass the vertical line test. So it fails the VLT. And VLT stood for vertical line test. So looking at some other ones here, if I drew vertical lines on this one, you can see it only ever touches the graph once. Over here though, if I drew one right there, it touches once there, but as soon as I move over, it touches twice there. So it doesn't pass vertical line test, not a function. And then these last two, if I drew a vertical line, okay, it's only ever touching once. Even as it's getting really, really steep, it's only ever touching once. Okay, so that passes the vertical line test, so it is a function. And then looking at this bottom right one, if I drew a line, say there, I can see it touches once, twice, 3, 4 times. So that one again fails the vertical line test. So all the ones on the right here failed the vertical line test. The ones on the left, they passed because it only ever touched once or less. As soon as it touches twice or more, not a function. So the next thing we're going to be looking at is some different examples of functions, and we're going to do these ones together. So we are going to answer the question, which of the following relations are functions? So we knew that if we had, say, 2 going to 5, 2 would then have to go to 5 again. So that one, it changed, so therefore it is not a function. And as soon as you find one point where it's not a function, you don't have to check the rest. You can stop there. So I'm going to go on to number 2. So with this one, 1 goes to 3, 2 goes to 3. You're allowed to have repetition over on this side, so that's okay. 3 goes to 4, 4 goes to 4, 5 goes to 4. So all of those are okay. If you don't even see any repetition over here, you don't even need to check on the other side. Okay, so that one, it is a function. Looking at number 3 here now, so we got a graph. So for those, you just want to draw vertical lines and see how many times it crosses. No matter where you draw a vertical line, it's only ever going to cross once. So this is a function because it passes the VLT. But looking at number 4, if I draw a line, say there, that hit 2 points. So again, as soon as you find one spot that doesn't pass the VLT, not a function. Number 5 here, we got some points. So 1 gave out 1, 2 gave out 2, 3 gave out 3, 4 gave out 4. So I didn't even have a repetition in the domain, so it's for sure a function. Looking at number 6, 1 gives out 1, and now 1 gives out a 2, and then 1 gives out a 3, and then 1 gives out a 4. So that can't happen. So 1, this is repeating, but it's giving out different values each time. So that can't happen. So therefore, it is not a function. So the domain repeats, but it has a different range each time. It was a 1, then a 2, then a 3. So it was changing, so it's not a function. So moving on into our function notation now. So our function notation, this is just notation for how we are going to write functions. So a function we could have as f. So this f and then bracket x bracket. The way we read this is we say it's f of x, or we could say f at x. So it's the function f evaluated at x. So the function f, that is just a letter that's going to be picked. So you could have a function that's maybe instead using the letter r, and you choose r because it stands for revenue. A lot of time in math, though, you're going to see f just because f stands for function. Okay, so looking at this next thing here, it says if y was equal to 2x plus 8. So here is a function. It's just written a little bit differently. The function notation for this is f of x equals 2x plus 8. So the only thing that was changed there was y changed into f of x. So y is equal to f of x. They essentially mean the same kind of thing. So in this next example, it says if f of x was equal to 2x plus 8, then f evaluated at 4 is going to equal, and we're going to figure out what that is. So the x here changed into a 4. So what we're going to do is we're going to take that x and it's going to change into a 4, and then we're going to evaluate that and see what we get. So 2 times 4, that's equal to 8, and then plus 8, we get 16. So therefore, we can say f evaluated at 4 is equal to 16, which means that would give us the point 4 and 16. We plugged in 4, it gave us out 16. So now we're going to move on to some different examples. It says consider the following functions. So we're given this function f of x is equal to 4 times x minus 1. And then we're given a second function, g of x is equal to 2x squared minus 5x. So the first thing we're going to calculate is f at 2, or f of 2. So we got to use the f1 because this one had f. So it's going to be 4 times, and then x is changing into a 2, right? That is the x. So it's going to be 4 times 2 minus 1. I'm just getting that from here. 4 times x minus 1. So 4 times 2 minus 1, that's going to give me 8. And then minus that 1, I'm going to get 7. The next one here, number 2, now uses g. So I know I'm going to have to use the g one. And I'm going to evaluate it at 3. So x is going to be 3. So it's going to be 2 times 3 squared, and then minus 5 times 3. Again, I'm just plugging in a 3 into where this x is here. So evaluating this part, 3 squared is 9, so I got 2 times 9. And then this, I got minus 5 times 3, that's just minus 15. Okay, and then this, 2 times 9 is 18, and then minus the 15 there. So we're going to get 18 minus 15, we get 3. Next one now, we're back to f again, so I'm going to have to use f. So we got 4 times, and now the x is negative 1. So 4 times negative 1 minus 1. So 4 times negative 1 is negative 4. And then when I simplify that, I get negative 5. Number 4 there now, we're back to g. So that is going to be 2 times the x squared, and then minus 5 times the x. Again, I'm using this one right up here. And then I just instead put in the number they gave me. So I put in that negative 2, and then simplify this. So negative 2 squared is going to give me 4. And then when I times that by 2, that's going to give me 8. So I got 8. And then negative 5 times negative 2, that is going to equal positive 10. So I got 8 plus 10, and that's going to give me 18. So those ones 1 to 4, I would say are the a little bit easier type. The next ones here, 5 and 6, I would say these ones are a little bit harder because these ones say determine x. Before we were just told what x was and we plugged it all in and then we got out our answer. Now it's like we're being told what this is and we are trying to find what value it is that gives us that number. So what you want to do is you want to write out this, f of x is equal to 11. But I knew what f of x was from before. F of x was equal to this right here, 4x minus 1. So I'm going to replace that down here. F of x is changing into 4x minus 1. And then we still have 11 on that side. So now what we have right here, that's an equation where we're going to try to solve for x here. So to solve for that, we got to add 1 onto both sides here first. Those will cancel. So we only have 4x equals, and 11 plus 1, we get 12. And now we just got to take the 4x, divide by 4 to get rid of that 4. Those two will cancel out. And so I get x is equal to 12 divided by 4, we get 3. So the value x equals 3, if you plugged that into f of x, it would give you out 11. Looking at the next one here now, number 6, it says determine x if f of x equals 35. So if you want to try this one, you could try to do it. So I'm going to write out f of x equals 35, and then I'm going to replace f of x with 4x minus 1. That's what it was up top. And then I'm going to solve this. So add 1 onto both sides. Those will cancel out. So we got 4x equals 35 plus 1 is just 36. And then just take that and we got to get rid of the 4. So divide both sides by 4. Those cancel out. And we get x equals 36 divided by 4 is 9. So x equals 9. So questions 1 to 4 I'd say were the easier type. 5 and 6 are a little bit harder. And then number 7 is really hard. So this one, okay, you're not going to see too many like this. This one's a little bit more difficult. So we are told f of x is equal to 2x squared plus 7. And we are also told h of x, so the function h, is equal to 3x plus 1. And then this notation here is like what we did up top. but it's a little bit more confusing. What it is we have the function f, and it's being evaluated at h of x. So we are going to put inside f of x, inside of that is h of x. So I'm going to start with f of x. So f of x was this right here, 2x squared plus 7. And then normally what we did was we were given a number, like 2, and then 2 went in wherever we saw an x. But now instead of evaluating it at x, we're going to evaluate it at h of x. So I'm going to instead put in 3x plus 1. So that is going to give me 2 times x squared, but x is now this h of x, 3x plus 1. So we put that in, 3x plus 1, and that was being squared, and then we still have that plus 7. Okay, so now I put it in. Now I can just simplify, and then I'll be done. So I'm going to keep this 2 in front. I'm going to do this squaring. So squaring means that we are going to write out what's in the brackets twice. So it's 3x plus 1 times 3x plus 1. And then don't forget the plus 7. So we'll keep this 2 here. And then we can do our foiling with these brackets. So 3x times 3x, that's going to give me 9x squared. And I'm just going to put my bracket in front of this 9. Then we also got 3x times 1. So that's going to be 3x. On the bottom, we got 1 times 3x. So that's another 3x. And then we got 1 times 1. And that's a 1. Okay, and then close our bracket, and then the plus 7 at the end. So now that I have that, I can take what's inside the brackets here, 3x and 3x, and I could put those together. So I got 9x squared plus 6x plus 1 plus that 7 on the very outside. And now what I can do is I can distribute this 2 into each part of the brackets here. So it's going to multiply by the 9, the 6, and the 1. So when I do that, I'm going to get 18x squared plus 12x plus, and then 2 times 1 gives me a 2. And then don't forget, still got that plus 7. So finally at the very end, I can take this 2 and this 7, and I can put those together. So I'm going to have 18x squared plus 12x plus a 9. So that is what our f of h of x is equal to. And again, that one's a little bit tougher, so if you thought that one was hard, that's okay. That one is a really tough question. So that is it for our notes. The last thing I'm going to write here now at the bottom is just our homework questions.